Alright guys, what's going on? I'm going to go over your Unit 4 review. Now, if you feel like I'm talking too fast, please slow down. I'm talking fast on purpose. Okay, just letting you know. So, if you do feel like I'm going too fast, please slow the video down. Alright, number 1. A 4-meter ladder leans against a house forming a 30-degree angle theta with the house. What is the value of cosecant theta? So here, this is my value for the length of the ladder, right? And that is also the hypotenuse. So this length right here is 4 meters. And then they say that the angle that is formed with the house is 30 degrees. So this right here is 30 degrees. Okay? So we're trying to figure out what cosecant theta is. And if you remember, cosecant is a reciprocal of sine. So sine theta is equal to opposite over hypotenuse. Therefore, cosecant theta is equal to hypotenuse over the opposite. So we have to figure out what this opposite is down here to the angle. And the way I can do that is using sine. So it's going to be sine of 30 is equal to the opposite, which is, let's call this x, over 4. And if I solve for x, it's going to be x equals 4 times sine 30. So if I go to the calculator, make sure you're in the correct mode, which is degrees. And so then what we're trying to figure out is 4 sine 30, and that is 2. So x is equal to 2. And then cosecant theta is hypotenuse over opposite. So cosecant of 30 degrees is going to be the hypotenuse, which is 4, over the opposite, which is 4 divided by 2, and that is equal to 2. So that's one way to do this. Or when we talk about cosecant being the reciprocal of sine, that means cosecant theta is equal to 1 over sine theta. So that means what else you could do is, this is a different method, is cosecant 30 is equal to 1 over sine 30, and just plug that into the calculator. So if you go to the calculator, 1 divided by sine 30, that is also 2. Okay, so those are 2 different ways you can get your answer. So the answer is 2. Okay. Number 2. So in Dewey Beach, building codes restrict the height of buildings to 55 feet. Using the diagram below, determine how much the building shown is above or below the code restriction. Okay, so here you have to remember that this height, the whole height is 4 plus whatever this value is right here. Let's call this x. Okay, so the total height is equal to x plus 4. So I have to figure out what x is. And I have x, I have this angle, and I have this adjacent. So that means I'm going to use tangent. So tangent of 45 is equal to the opposite over the adjacent, which is 60. If you solve for x, this is 60 tangent of 45. Okay, plug that into your calculator. And that is equal to 60. So that means the total height of the building is 60 plus 4, which is 64. But the restriction is that the building must be 55 feet. So we're over that, and we're going to be over that by 9. If I subtract 55, so minus 55, you're going to be left with 9. So the building is 9 feet above restriction. So the building is 9 feet above restriction. Okay. Number 3. If cotangent theta is equal to 3 over 4, what is cosecant theta? So we already talked about cosecant theta being hypotenuse over opposite. So if I draw my triangle, and let's say this is theta, I know this is the opposite, this is the adjacent, and this is the hypotenuse, right? Well, tangent theta is opposite over adjacent. Therefore, cotangent theta is going to be adjacent over opposite. And so here this is already a fraction. So that means the adjacent is 3 and the opposite is 4. And so I have a 3, 4, and then I have to figure out that other side using Pythagorean theorem, right? So 3 squared plus 4 squared equals c squared. 3 squared is 9 plus 4 squared, which is 16. 9 plus 16 is 25. And c is equal to 5 if you take the square roots of both sides. Okay, so the hypotenuse is 5. And so cosecant theta is hypotenuse over opposite. So cosecant theta is going to be equal to 5, which is the hypotenuse, over the opposite, which is 4. So 5 over 4 is your answer. Okay, number 4. Find the key features of y equals 3 sine 4 theta plus 1. So the period is 2 pi over b. And here the b value is 4. So 2 pi over 4. 2 over 4 reduces to 1/2, so this is going to be pi over 2. All right, now let's talk about the phase shift. So phase shift is what is inside the parentheses, and it's either the plus or minus. If it's plus, it goes to the left, right, opposites. If it's negative, it goes to the right, because to the positive side. All right, so, but there's none of that here, so this is not applicable. There's no C inside the parentheses. All right, now let's talk about vertical shift. So vertical shift is this last one. So it goes up 1 unit, and the midline is going to be at y equals 1. Okay. Now the domain of a sine function can go on forever, right? I can make as many rotations around that unit circle, so the domain is going to be all real numbers. Okay. Now let's talk about the range. So the range is bottom to top. And here this is a little different because on the range or the sine graph, I do have a minimum and I do have a maximum. It repeats, but I do only have that one. So let's think about our box, right? So this is my midline at 0, 1. And the amplitude is what tells me how much I go up and how much I go down, right? So here the amplitude is 3. So this is 3 up, and this is 3 down. So 3 up from 1, so 3 plus 1 is going to be 4. So up here, this point up here is 0, 4. And this point down here is 0, negative 2. Okay, so what the graph looks like is this. So the maximum happens at 4, and the minimum happens at negative 2. So my range is going to be from negative 2 to positive 4. So, and this is brackets because it is included in the range. So negative 2 to 4. All right, number 5. So the graph of y equals 4 sine of x minus pi plus 3 compared to y equals sine of x will have moved. So basically we want to figure out the transformations. So the minus pi means I go to the right, so it goes to the right pi units. Then the outside plus 3 is my vertical shift, so it goes up 3 units. And then the amplitude tells me my vertical stretch or compression. And so this 4 is greater than 1, so it's going to be a vertical stretch by a factor of 4. So, and vertically stretched by a factor of 4. And that's it. That's all the transformations for this equation. Okay, let's go to the next page, number 6. All right, number 6. What is the amplitude of the given graph? So here the given graph is a sine graph, and if I try to figure out the midline, it's in the middle. So my midline is right here at -2. And the amplitude is just how much it is to the top and how much it is from the bottom. Okay, so from here to here is a distance of 1, 2. So the amplitude is 2. And from here to down here is also 2. Okay, so the amplitude of that graph is 2. Hopefully everybody should be able to do that. Okay, number 7, write the equation of the graph using a cosine function. So we're using cosine. And then what I'm going to use is the window pane method. So this is, the good thing is that they only give us one cycle. So that's all I have to worry about. And here, this is the middle. And this is also the middle right here. Okay, so the midline is that middle of the window pane, which is right here at 60. So for sure, I know it's going to be some cosine function, x. I have to figure out what the period is. So let's say this is the period x. And it's 60, so I know this is positive. And then this is our amplitude. Let's say this is y equals. Okay. So our midline is 60, so that means it's going to be plus 60. Because it shifts up 60. Then I can figure out this using the amplitude. So the amplitude is the distance from the midline to the top and the midline to the bottom. So from 60 to 100, it's 40. From 20 to 60, it's also 40. So the amplitude is 40. And the reason I know it's positive is because it starts at the top and then goes down and then up, right? If it started at the bottom, then it would be negative. And last is the period, or the b value, basically, sorry. The period is 80, right? Because it takes 80 for one whole cycle. So 2 pi over b is equal to 80. But I want b, so I know b is going to be equal to 2 pi over 80. Now 2 pi over 80 simplifies to pi over 40. So this is pi over 40. That length right here. Okay, and that's that equation for that graph. All right, number 8. Determine the coordinate point of the minimum and maximum value of the following function within the first positive cycle. Okay, so first positive cycle, we're going to basically use our window pane just so I can see what's happening here. So I know this plus 5 means the midline is at 5, y equals 5. So let's call this 0, 5, this point right here. And then negative 15 is the a value, so I know it's going to start at the bottom, okay, since it's cosine. So it's going to start here, basically. And so it's 15 from 5. So this is 15. So 5 minus 15 would be negative 10. So this point down here is 0, negative 10. And then 15 up would be 5 plus 15. So that's going to be 20. So this is 0, 20. And that's up here. Okay. Now, the period is 2 pi. So that means, the period is 2 pi over b, which my b value is 2. So it is just pi. So this is pi, comma, negative 10 right here. right? Because this length right here is the period, and here the period is pi. So that means halfway between 0 and pi is going to be pi over 2. And so what our graph looks like is this right here. Okay? So that's the cosine because it starts at the bottom. So I know my minimum value is right here, and my maximum value is up here, right? That's the highest point. And so I know my y values, so the minimum is 0, -10, and the maximum is pi over 2, 20. So it happens at pi over 2, and the y value is 20. So that's how you find the minimum and maximum. Okay. Number 9. The shelf and bracket are shown below. The shelf is perpendicular to the wall. Note, the figure is not drawn to scale. What angle x in degrees does the bracket make with the wall? So we're trying to figure out this angle. So this is my hypotenuse, right? Because it's kind of rotated. And this is the opposite, and so this is the adjacent, but I don't need the adjacent. So opposite and hypotenuse, I know that I can use sine for that. So sine of x is equal to the opposite over the hypotenuse, so 2.5 over 3.2. But I want x, so I'm going to use the inverse sine. So x is going to equal to the inverse sine of 2.5 over 3.2. Okay, so if I go to the calculator, the inverse sine, remember, is the second on the sine. So inverse sine of 2.5 divided by 3.2. That's going to be 51.375. But if you look at the paper, it says round to the nearest tenth, so that's just one decimal spot. So this 7 is going to make this a 4. So the answer x is equal to 51.4 degrees. Yep. All right, number 10. Number 10, graph the function f of x equals -4 sine of 2 of x plus 1. Okay, so the first thing I'm going to do is figure out some of the key features. So like the amplitude. So if you look at the equation, your a value is -4, so that means the amplitude is 4. The period is 2 pi over b, which is 2. So that means the period is pi. And then the midline is from here, so the midline is y equals 1. And then a is negative, so it's going to start at the bottom. So if you start drawing your axes, and this is up to you however you want to do it. I'm just going to graph one cycle, and that's fine. If you just graph one cycle, that's all I expect you to do. So 1, 2, 3, 4. I'm going to use a scale of 4 for the x values. So and then I'll use a scale of 2 units for every one. Okay, so this is going to be 5, 4, 3, 2, 1. This is my x-axis here. This is -1. Sorry. So this is -1, -2, -3, -4. And then, like I said, I'm going to use a scale of 4. So 1, 2, 3, 4. This is pi over 4. 1, 2, 3, 4. This is pi over 2. 1, 2, 3, 4. This is pi. or no, sorry, 3 pi over 4. And then 1, 2, 3, 4, this is pi. So this is what I chose. You can choose whichever you prefer. And so now I can start using all these key features. So the midline is going to happen at 1. So at y equals 1, this is my midline. And what I'm going to use is the window pane to help me graph this. So the period is pi. So if I start at 0, and I'm going to go all the way to pi, and then I have to use the amplitude to figure out how high the box is going to go. So it's going to, the amplitude is 4, so I'm going to go up 1, 2, 3, 4. It's the top of the box, and then I'm going to go down 4. 1, 2, 3, 4. It's the bottom of the box. So this is what the box looks like, or the window pane, sorry. And then halfway in between is at pi over 2. And this is the midline. Okay. And so basically I know it's going to go from here, and since a is negative, it's going to go down, and then back to 0, up to top, and then back to 0. So it's going to look something like this. Okay, and so that's the graph of -4 sine of 2 of x plus 1. Okay, number 11, label each trig graph with its parent function. So hopefully you can start memorizing these. So this first one is going to be the sine because it goes at 0, 0. So this is f of x equals sine of x. This is cosine because it starts at 1. So this is f of x equals cosine of x. This is either going to be cotangent or tangent, and these two are the different ones. So the way you can remember is tangent is y over x. So at pi over 4, I have square root of 2 over square root of 2, and that's going to be positive 1, right? So that means this one down here is going to be tangent. So this one is tangent. And this one is cotangent. Okay, so tangent is going to the right. Cotangent is, oh, let's say tangent is going up, cotangent is going down. Okay, and then here, this one is going to be secant because it starts at 1. So this is f of x equals secant. And this is, since there's an asymptote here, this is going to be cosecant. And I'm going to have a Quizlet study set for y'all to try to memorize these, so hopefully you will be able to do that. All right, and then let's go to number 12. And these are also going to be included in that study set. So here, this one, the first one is going to be arctangent. Sorry. This one is going to be arctangent because it's approaching that pi over 2 asymptote. Right, it's kind of hard to see, but it has this asymptote right here. Oh. So this is f of x equals arctangent. Or tangent to the -1 of x, the inverse tangent. Okay, this next one is going to be arc cosine. So or cosine, the inverse cosine. And then obviously the last one is going to be sine, arc sine. And so the way I remember arc sine and arc cosine is that sine, my sine graph, goes through the origin, right? So the sine goes through the origin. Arc sine is also going to go through the origin. And then cosine is at 0, 1. So if I flip those, arc cosine is going to be at 1, 0. Okay? If you have any questions, please ask me. Send me a message on Remind. Don't forget your test is tomorrow, Thursday. If you're watching this earlier for some reason, this is on the test is on Thursday. Okay. All right.